All right, so let's talk about how to figure out which test is which. And I'm going to try and do this quickly or else this video could get long fast. So what I'm going to do is I'm just going to type along here with different types of statistical tests and see if we can pick what works. So let's say data is collected from a random sample to compare family income in Rochester and Buffalo. The researcher wants to see if she could show with high confidence that the average income in Rochester was higher than Buffalo. So the first thing I'm realizing is I have two samples. I have Rochester and I have Buffalo, and I want to know which one has a higher average. So if I'm working with two samples, I have two groups that I'm comparing, I'm going to use a two-sample test. So this is going to be a two-sample t-test. And let's see, it is going to be one-sided or one-tailed because I'm looking for a higher in Rochester than Buffalo. And what type of two sample is going to be either independent or dependent. And since I'm looking at Rochester and Buffalo, and those are two completely different samples, it's not a before and after, they're not from the same source, they're from different sources. This is an independent two-sample t-test. And then it's going to be one-tailed, and the other thing you have to do is you have to write some hypotheses for these. So my null hypothesis, H sub O is status quo, would be that the mean income in Rochester and Buffalo are the same. And H1 is going to be what we think we're going to find, that Rochester has a higher mean income than Buffalo. And that's that. All right, so we have the residents of Mineral City claim that because they're natural fluoride, they have fewer cavities. Last year, they learned that the countrywide average was 1.65, and they sampled 85 children and determined if it was less than that or not. So this time, we're only going to sample one group. We have a known mean of 1.65, and we're sampling one group to see if theirs is less than 1.65. So this is going to be a one-sample t-test. And when we do this one sample t-test, we are going to have a one-tail test because we want to look for a less than situation. It's not just different from, we want a less than. And our null hypothesis, H sub O is status quo. So H sub O is going to be Mineral City kids have 1.65 cavities, just like everybody else. And then our H1 is going to be Mineral City kids have less than 1.65 cavities. All right, a study of local gun control obtained samples from males and females regarding whether they were in favor of the gun control proposal. There was interest regarding whether there was a relationship between the gender of the voter and their voting status. So we're only sampling one group here, but then we're apportioning that group into two different character-based groups, basically. So this is a categorical sample. I'm not asking people to give me a number. I'm asking people to give me a word back. And when we have categorical sampling like that, where we're just counting frequencies, that's always going to be a chi-square test. So this is going to be a chi-square test, and we want to know if men versus women will answer the same in favor of or against gun control proposal. So I have two categories. I'm asking people two categorical questions. What is your gender, and do you favor the proposal? So this is going to be a chi-square test of independence. And my null hypothesis is going to be men and women. Well, let me rephrase this. This is better. The chi-square test of independence, those are the ones that have that general hypothesis. The general hypothesis being that two things are independent versus two things are dependent. So I'm just going to say gender and support of gun legislation are independent, and H1, gender and support are dependent. So again, chi-square test of independence, those are the ones, again, that have kind of a generic hypothesis, two things being independent, two things being dependent. All right, let's see. A study using sample data was done in the United States, exports and income derived by foreign investment. The goal was to use the data to predict the income on foreign investments based on import-export levels. So if I'm doing any kind of prediction, I want to use the data to predict other data I don't know about. That's when we're getting into the last thing we talked about, which is correlation and regression. So the goal is to use the data to predict the income based on export levels. So the thing that we're predicting is the dependent variable. So the dependent variable is income, and our independent variable is export levels. So again, how did I know that? It's because I was looking for a prediction. I want to predict one thing based on another thing. So that's how I set that up. 40 people who suffer from gout were randomly selected to participate in a special test of a new drug. The level of uric acid was measured before and again after they've been using the drug for 6 months. The goal is to determine whether reduction in uric acid levels was statistically significant. So here we have a before and after. I'm asking the same group of people the same question twice. Now, again, I'm not really asking them, we're measuring their uric acid levels, but still, I'm using the same group twice. This is a before and after. I'm taking 2 samples of the same group. This is going to be a 2-sample dependent t-test. It is one-tailed because I'm looking for a reduction only. So status quo would be uric acid before and after stayed the same, and H1 uric acid decreased after using the drug. An advertising researcher was interested in determining the criteria people use when choosing a new car. People are asked to select what they think is the most important factor in selecting the car. And they're given a list of cost, styling, performance, and reliability. They want to know if there's a preference. Okay, so this is where I'm sampling one group. I'm asking them one categorical question. So again, if it's a categorical kind of question, this is when we're going to be looking at chi-squared. This is a chi-squared just with one column, and it's apportioned into one list of things. So this is a chi-square goodness of fit. Okay, and our H sub O is there is no group preference toward one, toward one car factor. And H1 would be there is a group preference toward a certain factor. The generic version of chi-square goodness of fit, H sub O would be that the data is evenly distributed, and H sub 1 would be that the data is not evenly distributed, but I made it a little bit more tailored to the context. The organizers of a concert want to have a profile on gender, age, and preferred music style of all those who attended. As soon as I see that word all, or I see the word population, if I want everybody, I'm just going to use descriptive statistics. There's no inference here. I have everybody. I'm just going to collect their data and put it in a chart, because that's all I need to do. Don't need to make any inferences. Don't need to make any predictions. I have everything I need. And last but not least, a study was conducted to estimate the average dollar value of the benefits package for company employees. So this just says you're going to go out, you're going to ask a bunch of your friends, hey, what's your salary versus your health insurance premiums and things? Okay, there's my 2-year-old who's done with Curious George. So this, last but not least, is going to be a confidence interval. So hopefully this was quick and helpful. Max, do you want to say hi? You say hi?
Yeah.
Say hi.
Hi.
All right, there was Max, and I am done. Thanks for listening. We need a silly joke, Max. What kind of silly joke should we tell him? Should we tell him, knock, knock? Say, who's there?
The Easter Bunny.
Oh, the Easter Bunny's there. Well, there's your joke. Knock, knock. It's the Easter Bunny. Have a great day.